Yeah. So, hello everybody, and in this video we'll discuss about the questions that were asked in your daily quiz for the 4th week of June uh, regarding engineering mathematics. It was a tougher quiz, I would say, because some of the questions were tough, not like very tough, but as compared to the other quizzes, I think the difficulty level was slightly higher. Nonetheless, we'll try to solve them. Okay, so the first question itself is the trickier. Okay, they have given you a vector field v bar as minus y by r square I plus by r square into j, where r is square root of x square plus y square. Okay, and the counter integral of counter means I think the counterclockwise direction they are trying to say, but that is usually positive, so that's not the main thing. Of v dot ds, where ds is a tangent to the contour that encloses the origin. Okay, so this is the most important phrase in the question, I would say. Okay, and you are supposed to give the data as the answer, so there are no options also to do anything. That is okay, because options also would not have helped you in this case. Okay, so now if you see something like this, most of the students will think like we are supposed to use Green's theorem, because this Green's theorem is usually used to connect the line integrals with the surface integrals, right? But that would be a mistake here. Okay, why? Because we'll see. Okay, so for example, if you're solving this problem using Green's theorem, for example, let's say you are considering this v bar as minus y by r square into I cap plus x by r square into j cap. Okay, so in Green's theorem, what do? You basically consider this as some function, let's say m, and this as some function n. Okay, and then basically you're writing this as mi plus n j. Okay, and your objective here is to evaluate this integral v dot ds along this some closed contour. Okay, so they have not mentioned the nature of that, but you can see it is r equal to x square plus y square, so it's like a circle only. Okay, not more details are given, but you can imagine like that. Okay, so I'll not mention c because c is not there, so let it be. It's a closed contour, and by Green's theorem, you can write this as as a area integral of del n by del x minus del m by del y into dx dy. Okay, so this is Green's theorem. Okay, and most of the students, if they have studied this concept of vector calculus, they will use this and try to solve the problem. Okay, so here the difference, like the difficulty is, first of all, your m is minus y by r square, that is minus y by x square plus y square. So this del m by del y, if you do, you have to use u by v, this thing, u by v rule of differentiation. Okay, and that will be nothing but x square plus y square whole square, x square plus y square, then the derivative of minus y, that is just minus 1, plus minus y into derivative of x square plus y square with respect to y, so that will be just 2y. Okay, so this will be nothing but x square minus y square, no, minus x square one second. Okay, so you'll get something. I mean, the point is I don't want to do this the whole thing. Okay, so you can get some answers like this and then do the integration, or just for the sake of completion, this will be minus x square minus 3y square divided by x square plus y square whole square. Okay, and something like that also you'll get dn del n by del x also you'll get something like this, and then you'll evaluate, you know, this integral, and then you'll write this vds as some integral of a certain function. Okay, and solve. But the unfortunate part is, if you do this way, you'll get some answer. First of all, it's a lengthy process because you are supposed to do this and this also, but this will be wrong. This method is wrong, and that is the point that I wanted to make. That's why I'm not solving it complete, because it's a wrong thing. The reason is, you know, what they are telling you, that your contour encloses the origin. Origins means 0 comma 0. Okay, and if you put 0 comma 0, what happens to your vector field? That is y by 0 and x by 0, right? So your vector field is not defined at 0 comma 0 or origin, whatever you want to call it, and therefore you can't use Green's theorem. Okay, because like the underlying assumptions in your Green's theorem was, where whatever vector field you are integrating by converting into the area integral, it has to be defined for all the points in your contour, and the derivatives of the components, at least the first order derivatives, should be continuous. Okay, but here, since v bar is not defined at origin 0 comma 0, Green's theorem cannot be used. Okay, so that is the problem, that even if you follow this lengthy procedure, and if you are using Green's theorem, anyway you will not get the answer. So then what to do? That is the question, because anyway you are supposed to solve this question, right? So you are supposed to use this other hint, that r is square root of x square plus y square. Okay, and then what you can do is convert this, convert this problem to polar coordinates. Okay, and then you will get the answer. So in polar coordinates, we know that x will be r cos theta, y will be r sin theta, right? And then r is x square plus y square, that is fine. And then, and here, since r is square root of x square plus y square, which is, considered as constant. So they have not mentioned that the radius is also, the contour is also deforming or anything. So you can treat this as constant radius contour. And then dx will be r minus sin theta d theta, and dy will be r cos theta d theta. Why we are doing this is because you are supposed to evaluate this integral, right? So, this will be nothing but integral v bar. So v bar, if you write it in polar coordinates, y is r sin theta, and r sin theta minus sin is there, divided by r square, that is I cap, plus x by r square, so that is r cos theta r square j cap, and then you are supposed to take the dot product with dx plus this thing, right? Dxi plus dy j cap, right? And this also you can write from here. So this will be nothing but minus r sin theta d theta I plus dy is r cos theta d theta j. And then you are supposed to take the dot product. And then what happens? If you take the dot product of the I terms, then what do you have? Basically, you are still doing this integration with respect to d theta now. So one r square will get cancelled. So you'll have sine square theta d theta from the first term when you take the dot product. And from the second term, again, r square gets cancelled and cos theta into cos theta. So that will be cos square theta d theta. And then sine square theta plus cos square theta is 1. So this is just integrating your theta along the circle. Okay. And that is just 2 pi, right? Because since theta is varying between 0 to 2 pi. Okay. And then pi, you are supposed to do it at a data entry type of thing. So 2 into pi. That will give you 6.283. And that should be your answer. Okay, so the answer is not what you get by using Green's theorem. The answer is this one. Okay, just let me check whether it's correct. Yeah, it's the correct answer. Okay, so this was a trickier problem because first of all you should know that since they are enclosing the origin and your vector field is not defined at the origin, Green's theorem is not applicable, because that is the most common way students will go to solve this problem. And this other hint was given that r is square root of x square plus y square. So you are supposed to use that and convert the problem into polar coordinates, and then everything simplifies pretty quickly. Okay, because you use this also, dxi plus dy. I mean, this is nothing but your ds bar is nothing but dxi plus dy j. Okay, and that is the piece of information that you use and then do the calculations. Okay, so interesting question, tricky question, but if you understood Green's theorem properly, you should be able to solve that. Okay, now let's move on to the next question. Okay, so in this question again they are asking you to find area. In previous quiz also, third week of June quiz also, such questions were there. Okay, and here what you are supposed to do is basically use the concept of mod. So first of all, you are supposed to plot y mod x minus 1, right? That is first equation. So if you see, so in the first quadrant x is greater than 0, and in that case this equation will be y equal to x minus 1. Okay, so that is nothing but line of positive slope with negative intercept. So it is something like this. Okay, so this is the y equal to x minus 1 line, and we are drawing it for x greater than 0. Okay, so that means it is only in this region. So this will be 1 comma 0, this is 0 comma minus 1, and when x is negative, so here x is negative, right, in these two quadrants, second and third. So in that case this will become y equal to minus x minus 1. Okay, so that is nothing but negative slope, negative intercept. So if I put x equal to 0, is minus 1, and if I put x equal to minus 1, that is 0. Okay, so it is something like this. Oh, sorry. Okay, my drawing is not up to the scale, so you need to forgive me for that. And this will be 0 comma minus 1 comma 0. Okay, and now the next this one. So here also you are supposed to do for x greater than 0, this will become y of minus x plus 1, because mod x is just x when x is positive, and y is minus x plus 1, negative slope, positive intercept. So it is here. Okay. This will be your third line. So this is y equal to x minus 1. Oh, minus x plus 1, sorry. Minus x plus 1. And x less than 0, this will become mod x will be minus x. So this will become minus of minus x plus 1. That is x plus 1. One second. Yeah, this is x plus 1, right? second. Yeah, minus x plus 1 is okay. Yeah, this is fine. Yeah, this fourth. Okay, so this is the y equal to x plus 1. Okay, so basically, if you look at this, it is a square. This area is a square with side equal to square root of 2, because this length is 1, this length is 1. So by using like this right angle triangle hypotenuse formula, Pythagoras theorem, it is square root of 2. Okay, so therefore the area bounded by lines y equal to mod x plus 1, and what is the second line? Mod x minus 1 minus mod x plus 1. Okay, this is minus 1, and y equal to minus mod x plus 1 is nothing but equal to square of the side, because it's a square, so area is side square, so that is just 2. Okay, and that is option number B. That is also correct answer. Okay, so similar question has been asked in the previous quiz also, so you should be comfortable with this by now. Just keep one thing in mind, whenever there is mod x. Okay, so this hint you can use everywhere. Whenever there is mod x, for x greater than 0, it is just x. For x less than 0, it is minus x. Okay, and if you remember this, you will be able to solve these problems with ease. And the same thing is applicable for mod y also. Okay, if it is greater than 0, it will be just y. If it is less than 0, it will be minus y. Okay, so let's move to the next question. Yeah, so this is an interesting question. So if you look at this differential equation, first thing you should understand if you had attended the regular classes is that this is Euler-Cauchy differential equation. Okay, because there are x square and 5x, it's not just d2y by dx square, there is x square also, which is the independent variable. So it is still a linear ODE, but the coefficients of the differential terms are not constants. They are functions of the independent variable x also. So that is the standard Euler-Cauchy equation, differential equation. And the standard way to solve this kind of differential equations is to put x equal to some e power t. Okay, it is a standard substitution that we do. We have done this in our regular classes on multiple occasions. Okay, and then you solve. How do you solve? Okay, so before that, let's write this ODE once again here. Okay, so given ODE is nothing but x square into y double dash plus 5x into y dash plus 4y equal to 0. Okay, have they given any other information? No. And what they're asking is solution of this differential equation, which is y of x. What does it have? A polynomial, fractional powers of x and all those things. Okay, so here you can first write this in the context of differential operator as x square d square plus 5xd plus 4y 0, where d is nothing but d by dx. Okay, so this is the differential operator that we use, but this is not solvable in this fashion. So then we put x equal to e power t. The reason why we do this substitution is because if you do that, then you can write xd as d dash. And what is d dash? It is d by dt. Okay, and similarly x square d square, you can write d dash into d dash minus 1. Okay, and therefore your equation 1 modifies as d dash into d dash minus 1 plus 5xd is just d dash plus 4y equal to 0. Okay, then you can simplify this as d dash whole square plus 4d dash plus 4 into y equal to 0. And if you look at this, it is a perfect square, right? So therefore you can write d dash plus 2 whole square into y equal to 0. Okay. And then, then you can solve this in a regular sense. Since RHS is 0, it's a homogeneous ODE, so there will be only complementary function, no particular integral. And to find this complementary function, we use this auxiliary equation. Okay, these terms are discussed at length in our regular classes, so we are not going there again because it will take a lot of time. So here we are supposed to find the complementary function, and that will be the complete solution. And we use auxiliary equation. And what do we do that? In that auxiliary equation, wherever you have d operator, here it is d dash, just put m in that place. Okay, and then solve for that. Find the roots of this auxiliary equation. So if you look at this, the roots of auxiliary equation are -2 and -2. Okay, so these are real and repeated roots. Okay, so therefore in such cases your complementary function is nothing but y equal to c1 plus c2t and e power -2t. Okay, since it is repeated, this kind of factor is multiplied by e to the power minus mt. So m is -2 here, so it is e power -2t. Okay, but this is not the final answer, right? Our equation started from x and y, but here we are getting y as function of t. So we are supposed to do the back substitution. Since your x is e power t, your t is nothing but ln of x. Okay, and therefore your complementary function becomes y equal to c1 plus c2t, so that will be c1 plus c2 into ln of x, and e power -2t, so that will be e power -2 ln of x. Okay, so it can be further simplified as c2 ln x, and this will be x power -2, and this is your complementary function. This is your solution also. Okay, so now what they are asking in this question is, if you do this, what are the terms that are present in your solution? It's not a polynomial. Okay, finite series, no, it's not a series. Consists of negative power of x, true, and logarithmic function, yes. And the D option says exponential functions. No, it has negative powers of x also, right? So therefore option C is the correct answer. Yeah. Okay. So this is the classic case of Euler-Cauchy equation, and there is a fixed solution methodology to it. And if you remember that, you should be able to solve this question with ease. Okay. So now with that, we'll go to the next question. In the next question, they are asking you to find the arc length of the curve. And this curve R bar is parameterized with some variable t. Okay. So this is also we have discussed in our regular classes. So, if you have a parameterized equation of curve, let's say R bar, which is parameterized by t, and it is nothing but x of t I cap plus y of t j cap plus z of t k cap, then the arc length is given by the formula, which is nothing but the magnitude of dr by dt. Okay, so that means you are supposed to differentiate r with respect to t each and every term, and then take the magnitude. Okay, so that formula, and yeah, so since it's a parameterized, you are supposed to integrate also, no? Yeah, so then you are supposed to integrate with respect to t because t is there, no? So here the t is going from 0 to 1, so limit will be 0 to 1. Okay, but we usually don't write it in this way. The formula that I have given you in the class is nothing but, since we are finding the magnitude, this will be dx by dt whole square, dy by dt whole square, and dz by dt whole square, and this is nothing but integrated after outside. Okay, so now here you can directly solve this. Okay, so your x is nothing but sin t, y is minus cos t, and z is root 3 into t. Okay, so therefore dx by dt is cos of t, dy by dt is sin of t, and dz by dt is just square root of 3. Okay, and therefore your arc length, if you put this in the formula, will be integration from 0 to 1 square root of cos square t plus sin square t plus root 3 whole square multiplied by dt. So we know that sin square t and cos square t summation is always 1, plus 3 is 4, square root of 4 is 2. 0 to 1, 2 dt. Okay, and that is just 2 into 1 minus 0, that is 2. So the answer should be 2. Okay, that is option number D. And that is also as per your answer key. Okay, so standard formula, standard problem, but the key here is you are supposed to remember the formula. Without that, you can't solve this. Okay, now let's move on. So the next question is about limit. Okay, so x is tending to infinity, e power x and x square. So x tending to infinity, e power x divided by x square. So if you put x equal to or x tending to infinity here, you get infinity by infinity form. Okay, and for such cases, you are supposed to use L'Hospital's rule. Okay, so then basically you differentiate numerator once, it still remains same, but x square becomes 2x. It is also still infinity by infinity. Okay, when you put the limit of x tending to infinity, differentiating one more times, numerator remains the same, denominator becomes 2. Okay, and then if you put x tending to infinity, this limit will be infinity. Okay, you can't do any more differentiations because denominator is a constant now. If you differentiate further, it will become 0, and that's, I mean, that is not the correct way. Okay, in L'Hospital, you keep on differentiating numerator and denominator till they are some functions of x. Okay, once they are becoming constant, you don't do that anymore. Otherwise, where will you stop? It is the point. So here there is no finite limit. The limit value is e power x, and this is the mathematical way or the formula-based way, L'Hospital's rule. But you can think of this as well, that exponentials increase at a faster rate than the square functions when x is very large. Therefore, their ratio will always be keep on increasing. It will not converge to a finite number or quantity. Okay, because the rate of increase in the exponential function is always higher than the rate of increase in the quadratic function. Okay, for even for that matter, I think x cube also, if you take cubic functions, then also the answer will be infinity only. Okay, that is about this limit. So the answer will be option C. Okay, and that is also given as per your answer key. Correct answer. Okay. So it is not always that you'll get the finite limit if you use L'Hospital's rule. Okay, that is not always guaranteed. Okay. So now let's move on to the next problem. Okay. So they have given you a differential equation, dy by dx equal to x minus y whole square, and they have given you additional information that at x equal to 1, y is also 1. And then there are 4 options. See, we can solve this conventionally, we'll do that, but there is an easier way. You have options, you can eliminate some of them. So let's see if we can eliminate these options and get the only one option correct. Rarely happens, but if it happens, that's good, no? If I put x and y equal to 1, option A log 1 0. Option A is okay. Yeah, it doesn't help doing this option wise, so we have to do it conventionally because more than one options could be correct. So here, the one thing that you should notice in this kind of questions is, usually in this kind of problems, whenever you have x plus y, x minus y, y by x or x by y terms, usually think of it by solving by doing substitution. Okay, so here also that is the easier way to do. Okay, so what you can do is put some t equal to x minus y. Okay, so in that case, you can write dt as dx minus dy. So therefore, dt by dx will be 1 minus dy by dx. Therefore, this dy by dx will be 1 minus dt by dx. We are doing this because in our differential equation, let's call this as equation 1, there is a dy by dx and x minus y square, right? So this given equation modifies as 1 minus dt by dx equal to t square. Okay, and now you can do further simplifications and then use the separation of variable method. So let's do that. So you have dt by dx as 1 minus t square. Okay, and therefore you can write dt by 1 minus t square as equal to dx. Okay, this is nothing but a square minus b square formula, right? So this will be 1 plus t, 1 minus t equal to dx. Okay, now you can use partial fractions to further solve this, because on the LHS you can just do integration with respect to x, but if you want to do this on the LHS, you have 1 by 1 plus t into 1 minus t, right? So you are supposed to use partial fractions here. So how do you do that? In that case, basically you write this 1 by 1 plus t 1 minus t equal to a by 1 plus t plus b 1 minus t, and then solve for a and b. You'll get two equations, two unknowns. The first thing that I can write from here is a plus b must be equal to 1. Okay, maybe I'll not skip that step, otherwise somebody might get confused. So you can write this as 1 plus t is okay, 1 minus t remains the same. This will become a minus at plus b plus bt. Okay, or in other words, I can write this as a plus b and b minus a into t. Okay, so I can write this as a plus b minus a into t. Okay, and since there is only 1 here, so a plus b has to be equal to 1 and b minus a has to be equal to 0. That means b has to be equal to a and ab has to be, summation has to be 1. So that means a and b equal to half. Okay, so therefore what you can do, you can write this as 1 by 2 divided by 1 plus t plus 1 by 2 1 minus t dt, and on the RHS you just have x plus c. Okay, so that 1 by 2 comes out, and this will be integration of 1 by 2, so that will be ln of 1 plus t, and this is also integration of 1 minus t, but there will be minus sign here. Okay, so this will be x plus c. Okay, and then the property of log, so this will become 1 plus t divided by 1 minus t. I'll take 2 on the other side, and this c will become 2c, so let's call it c dash. Okay, and now you can do the back substitution, because we put t equal to, what did we put? T equal to x minus y. Okay, so if you put it back, okay, in that case what happens? This becomes 1 x minus y 1 minus x plus y equal to 2x plus c dash. Okay, and now what is the information that they have given additionally? That at x equal to 1, y is also 1. Okay, so if you use that information here, that means ln of 1 is equal to 2 plus c dash. Ln of 1 is equal to 2 plus c dash. Ln of 1 is 0, so therefore c dash will be minus 2. Okay, therefore your final answer is ln of 1 plus x minus y divided by 1 minus x plus y. Okay, equal to 2x minus 2. I can write it as 2 into x minus 1. Okay, now let's look at the options and try to figure out. 2 into x minus 1, that is only in the last option, no? And yeah, this negative sign is coming because they are writing, inside the log, they are swapping the numerator and denominator. So therefore, option D has to be the correct answer. Yeah, it is also true. So now you see, in this problem, what they are doing, they are not writing ln of 1 plus x minus y divided by 1 minus x plus y. They are reversing it. So that's why negative sign is coming. Okay, and I hope that much is clear to you because that's the pretty common property of logarithmic functions. Okay. So this is the classic question where you are supposed to solve it by using substitution. Okay. If you do that, the rest of it is a linear algebra and without doing any calculation mistake. In between, you are supposed to use the partial fractions and then solve it. Okay. So good question, and these kind of questions are expected in your GATE exam also. You may ask in this question, how will I get the idea that I am supposed to use the substitution? Look at the options. Because in options B and D, there is x minus y, right? And in the denominator, it is minus x plus y. That means it is negative of x minus y. So sometimes options also help you in order to guess which will be the correct method to solve this kind of problems. Okay. You can, I'm not sure, but if you put y equal to vx, that substitution, if you use y equal to vx, you may be able to get the answer. Okay, but I have not done that way. You can try that. You can take it as a homework and try whether you get the same answer or not. That is the thing to see. Okay, but y equal to vx also is a possible method to do. Whether it's easier or difficult, that you have to do. You have to check. Okay. So with that, let's move on to the next question. Okay, so this is, I think, the last question. So here what they are saying is, a number is perfect if it is equal to sum of all its proper divisors. Now the first question mark is, what are proper divisors for a number? That is the definition of a perfect number. That's fine. We roll two standard 6-sided dice. Okay, so 2 dice are rolled. What is the probability that the product of the numbers that appear on 2 faces is a perfect number? The product of numbers are perfect number or not? That is the question. See, when you toss 2 dice are tossed, total possible combinations for product. I mean, in this question, what they're asking is the number that appear as, and like each die will have one number, right? But their product will be another number that has to be a perfect number. But how many such product numbers are possible? That will be 6 into 6, right? 36. So when 2 coins are tossed, total possible combinations for the product appearing on product of numbers appearing on the dice, on the face of dice, will be 6 into 6, right? That will be 36. For example, if I am rolling a dice and if I get 1 and 1 on both the dice, then their product is 1, right? Similarly, if I roll and both 6 and 6 are there, so there will be, product will be 36, right? So I'm saying total possibilities are 6 into 6, 36. Some of them will be repeated. For example, if I take 2 and 4, it will be 8. And similarly, if I take 4 and 2, that will also be 8. But that is okay. I am not saying these are all distinct possibilities. There are total 36 possibilities. There could be repeated product also. I mean, number which is a product. It can be repeated also. That is okay. Okay. So that is not the problem. The problem is about this other part of the question where they are saying, talking about a perfect number. Okay, so first of all, you should know what are the divisors and then what are the proper divisors. For example, if I take, let's say, a number, let's say 7 or maybe 9. So the divisors mean, divisors of this number means the numbers with which I can have a integer factor. Or if I divide by that number to 9, there will be integer quotient. So that means divisors will be 1, 3, and then 9 itself. Okay. So then there are proper divisors. These are total divisors. Proper divisors means you include, you exclude the number itself. So proper divisors will be only 1 and 3. Okay. And perfect number means if you add these proper divisors, 1 plus 3, it is coming out to be 4, but that is not equal to 9. So therefore, 9 is not a perfect number. Okay. By this definition, I mean. Okay. So perfect number means this one, that if you do sum of all the proper divisors means divisors excluding the number itself, then the sum has to be equal to the number itself. Okay, and that doesn't happen with every number. Okay, so that is the main part in this question. Okay, so like it's difficult in your exam hall to do this, but if you have ample time, you can do it. But this is one of those questions that if you know, you can easily solve it, but if you don't, it will take a lot of time. Okay, so how do you find perfect numbers? Because we are interested perfect numbers which are less than 36 only, right? We are not supposed to go beyond that because product cannot be greater than 36 in our problem. But how many numbers are there less than 36 or equal to 36 which are perfect numbers is the question. One thing is you can do by hit and trial. Take numbers like 1 to 10, 10 to 20 and like that. That is the best way if you don't know anything about perfect numbers. But I'll give you one formula. You are not supposed to remember that formula, but that is a general formula that is used for finding perfect numbers without doing brute force analysis. Okay, and the formula is the formula is 2p power minus 1 multiplied by 2 power p minus 1, where this 2 power p minus 1 is a prime number. Okay, so then only the product that you'll get will be a perfect number. No need to remember this formula, but since we are solving it, I thought I'll just tell you. This is also called as Euclid-Euler theorem. No need to remember all these things. Okay, but the smallest prime number that you can think of is, like p value has to be, 1 or greater than 1 integer. Okay, so if I take p equal to 1, that means 2 minus 1 is 1. Okay, so 1 is not a prime number, so you can't use that. If you take p equal to 2, that will be 2 square minus 1, 3. So it is a prime number. So you can use that. So the perfect number will be 2p minus 1, that is 2 power 1 into this 2 power 2 minus 1, that is 2 into 3. So that is 6. So 6 is a perfect number. You can verify that. What are the divisors of 6, 2, 3 and 6. So you exclude this. So 1 plus 2 plus 3 is 6. Okay. So like that, if you do p equal to 3, then 2 power 3 minus 1 is 7. It is also prime. Okay. So therefore, the perfect number associated with this will be 2 power p minus 1. So that will be 4. 2 power 2 into 7. So that is 4 into 7, 28. And you can verify 28 is also a perfect number. And if you take p power 4, that will be 16 minus 1, 15. So that is not a, that will be not giving you a prime perfect number. Okay, so those are higher numbers also. So, you know, there are only two perfect numbers within your range. One is 6. Oh, sorry. One is 6 and one is 28. Okay. There are two perfect. You can do this by, as I told you, take each number and verify whether it's a perfect number or not. Between or less than or equal to 36. And those numbers are 6 and 28. So now how can you get product as 6? When you throw two dice, it could be 1 comma 6 or 6 comma 1 or 2 comma 3 or 3 comma 2. So there are four ways. But can you get 28 as the product? It's not possible, right? Because 28 is 7 into 4. And when you roll a dice, you don't have 7, no? So therefore, no case is possible in which you'll get 28 as the product of numbers on two dice. Okay, because the numbers are maximum up to 6. So 6 into 6, 36 is possible. 6 into 5, 30 is possible. 6 into 4, 24 is also possible. But 28 is not possible. Okay. So there are only 4 favorable cases. Okay. And therefore, total cases are 36. So the probability of this event will be, to get the perfect number is 4 by 36. That is 1 by 9. Okay. And that will be option B. Okay. And that is the correct answer. Okay. So this is an interesting question. But if you figure out the perfect numbers, then it's not that difficult. Okay. So I think this is the end of this quiz, and with that we'll stop and we'll meet next time. Okay. Bye.